Guys, welcome back to my channel. I am yours Rahul. So in last video I posted the Springboot part 1 course. It is the continuation of that, which is in this video I will cover the core concepts like the beans, profiles, annotations, dependency injection, JPA, entity, like all these things I will cover, and these things needed for the basic CRUD operation, and whatever I am going to cover in this video, it will completely theoretical, no coding or nothing will be there, but it's needed for your MCQ as well as your hands-on, because if you understand these annotations, these things, then it's easy for you to go for the hands-on part, like what to say, the annotations that I'm telling, like the component service and entity like ID. So in these things you will get a vision, get a view, like where to give these things and what's it purpose, like that. So let's get into it. So Springboot core concept, the part second video. So in core concept, it is the first thing, dependency injection and inversion of control. So what is this? First of all, inversion of control, IOC. Actually, it is a fundamental design principle where control over the construction and the life cycle of object is inverted from the application code to a container or framework. Actually, it allows for decoupling of components and what to say, promoting modular and reusable code by delegating the responsibility of managing dependency to an external entity, like that IOC. And in case of DI, like the dependency injection, it is like a what to say, specific implementation of IOC, where dependencies are injected into a class rather than the class creating or managing its dependency. Like if we use DI, means with DI classes are loosely coupled, make them easier to test, maintain and extend. That's the purpose of DI. And Spring framework leverages DI through annotations like auto-wired. I think you guys know these term, auto-wired and XML configuration, like that, which allowing developers to wire dependencies without explicitly instantiating objects. And by using DI, the developers can create more flexible, like, and more modular applications, so that the components can be easily replaced or configured. And DI promotes the principle of separation of concerns, and as classes focus solely on the core functionality without worrying about dependency management. And the Springs IOC, its container manages the life cycle of beans. It will, the beans thing will be explained in for the slide, and it's including instantiating dependency injection, destruction based on the application configuration, and understanding IOC and DI, means these two concepts is essential for mastering Spring framework and building enterprise grade application. Like this annotation, entity, the XML thing, everything will be come under these things, this IOC DI thing. So you have to get a more idea. You have to get more close with these things. Then only you can develop a good functionality, good functional backend codes, like that, using Spring Boot. So second, annotation. Actually, it is used to provide metadata to the Spring framework, which is allowing it to understand how various components should be managed and configured. And it's a key aspect of Spring Boot, as they help simplify configuration and reduce boilerplate code. In last video, I just explained what is boilerplate, which is used to reduce minimum or same type of codes, like no variation of same type of code. And annotations like component, service, repository, which is already we saw in our mini project thing also. So it's a part of Spring stereotype annotation which provide metadata to Spring container. And these are some annotations that I will explain. First of all, that component. It's a generic stereotype annotation used to annotate classes and Spring managed components, indicating that they will be auto-detected and registered by the Spring container. And a service, which is a specialization of component and is typically used to annotate classes representing business logic or service components in the application. And repository, another specialization of component used to annotate classes representing data access objects or repository components for data access. These three are some. In my website I posted almost 70 plus annotations with its some sort of description, so that you will understand what all annotations are using. And I will show you. So this is the site. In this annotations, here I posted the annotations with some description, like what is this annotations are using and its functionality, like that, so that it's easy for you to go through it, which needed for your MCQ also. So based upon that, just to go through this annotations. And in your MCQ, the things that they will ask based upon this one means uh, what to say, in syntax based at bean, then some syntax question, and at configuration, like that the question will ask. So if you understand these annotations and its functionalities, then it's easy for you to understand what's the purpose they asking in that question also. So based upon that, try to go through this annotations that are present in the website. So I will give this in my description, you can go through that. Next is the bean scope. It's defines the life cycle and visibility of Spring managed beans within the application context. So the default scope in framework is a singleton. There are some other type: prototype scope, request scope, and these types. So first of all, in singleton, it means that only one instance of the bean is created or and shared across the entire application context. And the prototype scope, it instructs the Spring container to create a new instance of the bean each time it is requested. And the last one, request scope, it creates a new instance of the bean for each HTTP request in a web application, while section scope creates a new instance for each HTTP section. So it's like based upon the bean, based upon the scope, it will create the bean, like that it's mentioning. Next is the profile. Profile in Spring, which allows the developer to define different configurations for different environments, such as development, testing, and production. Like what to say, for in the different configuration means in test case that we configure so many things will be different when we compare to the main class repository class, like that we mentioned, like the profiles changing based upon the development, testing, and production cases. And the beans can be associated with specific profiles that ensuring only the beans relevant to the active profile are loaded into the application context. Means only the active one will loading into the application context. That will be ensuring by the thing. And profiles are activated based on specific condition such as environment variables, system properties, and or configuration settings. Like what to say means, in the system properties application, in the code also there is application property. Based upon that, it will change. Mm, one one example related to this is the port that we are using, like a local host port. In that, the default port will be 8080. In the application port, if we give some other port like a server dot port in a particular number, like 8000 to 3000, like that, it will go to that particular port only. Like that, it will change. By leveraging bean scopes and profiles, developers can customize the behavior of their Spring application to meet specific requirement in different runtime environments. So the thing is, Spring also supports custom bean scope, allowing developers to define their own scopes tailored to specific use case. And these two things, like a bean and a profit, which is also essential for Springboot, that is used for building flexible, configurable, and modular Spring application that can adapt to various deployment scenarios. Next is the important concept, like the in mini project I showed you. It's required these things like that annotation and these type of request mapping, get mapping. These type of mapping things are mostly, not mostly, is giving in the controller section. Like what to say, to map to this thing, like that it's mentioning. So what is REST controller, what is controller, like that we can see now. So REST controller is like it's to it's responsible for handling HTTP request and returning appropriate responses. And these controllers typically contain handler methods like the request mapping, get mapping, post mapping, put mapping, or delete mapping, which is specifying the HTTP method and URL mapping for each endpoint. Then REST controllers encapsulate the logic for processing requests, interacting with business logic or service layers, and returning the desired response, often in the form of JSON or XML data. And it's the common way that Springboot returning their output, like the JSON or XML data, mostly in JSON file format. So in last video I already mentioned, like the developer need to focus on the business logic rather than the infrastructure or something. So in this, the REST controller is encapsulating, means what to say, like joining the logic and returning the response, like that, showing the functionality only. Then response body annotation. So what all annotation that I given here, all these explanation is given in the site. So if you didn't get any valid point, means anything from this thing, just go to the website also. So the response body annotation, which can be used in conjunction with REST controller or on individual handler methods, to indicate that return value of the method should be serialized directly into the HTTP response body. And cross origin resource sharing. This thing is like Springboot further simplifies the process of building RESTful APIs, which auto-configuring components and providing embedded servlet containers for deployment. So Test controllers can be done using Spring Mock MVC framework also, and in testing cases, like in test cases, it will be using Spring Mock MVC framework, and somewhat different from the thing that we commonly using in our main class, like that we can say. That's the thing here mentioned, that through integration test that send mock HTTP request and validate the response. That's why in some cases the test case will fail, um, even though the code running successfully. The compilation will be okay, but based upon the test cases, it will fail. So that you have to check the test case also in what format it's given, like that. Next, request mapping, get mapping, post mapping, like that we can check. So request mapping is a versatile annotation used to map HTTP requests to specific handler methods in Spring MVC controller. It supports attributes like value, method, params, headers, and consumes. In this value, params, these two things we already saw in the project. Like value is to get a particular string or something, like that we can check, and get mapping, post mapping, these for mapping is resemble to the get, post, put, and delete requester respectively. So in get mapping, it is used to read the data, and post for uh, creating new data, and put mapping is to update the already stored data, and delete mapping is used to remove resource from the server. So this is the usage of these four mapping. And in addition to mapping HTTP request, this annotation can also be used to define the media type consumed or produced by the handler method using the producers and consumes attributes. By combining request mapping annotation with path variables, request parameters, and request headers, developers can create powerful and flexible APIs that cater to a wide range of use cases. So rather than this, the request mapping and its specialized variants support flexible mapping options, which allowing developers to define complex URL patterns and handle multiple HTTP method for the same endpoint, and specify request parameters or headers as condition for mapping. Then Spring MVC also possesses request mappings in a specific order, like what say, with more specific mappings taking precedence over less specific ones, which allows for fine-grained control over request handling and dispatching. That's the another usage of mapping thing, and Spring MVC. So understanding the nonsense of request mapping annotation is essential for designing RESTful APIs that other two best practices promote code and maintainability, as well as provide a seamless experience for clients consuming the API. Next is the request and response entities. So request entity represents the data sent in HTTP request, and typically in the form of JSON or XML payloads. Like what to say? Okay, the example of request thing is like thing is like the post method, like the data we are giving through post method is somewhat like a JSON format, like stored into the database, like that we are giving. So it will be in the form of JSON file. Then request entities can be mapped to Java objects using Spring's data binding mechanisms such as request body in controller methods. which automatically deserialize the request body into Java objects, and which the Spring MVC automatic conversion between JSON and Java objects, like using libraries like Jackson or JSON, allowing developers to work with Java objects and controller methods without manual conversion. Same like request response entity represent the data returned in an HTTP response, which is also being like a JSON format. If you have to check how it is the format that the request and the response, just do one thing. After doing the project, just use the Postman application, and in that just upload the data in a JSON format and try to get the data. Then in the get section, it will be in a JSON format only, the data returning. And JSON entities can be generated dynamically, means responses entities can be generated dynamically in controller methods using Spring's response entity class, which allows developer to customize HTTP headers, status codes, and the response body. And the last one, error handling. So error handling is like the try catch method. Like that we can say. Then another thing is the by designing request and response entity that closely align with the business domain, developers can easily create APIs that are intuitive, self-descriptive, and easy to consume by clients. Then Springboot's auto configuration feature simplify the process of serializing and deserializing JSON data by automatically configuring the Java objects using libraries like the JSON on the dependency present in the project. Then actually if you know about the request and response entities a lot, then it is like a efficient, scalable, and maintainable thing that defines the contract between the client and server and influence the overall usability and performance of the API. Like you can easily understand in what form to give the data, in which form to get the data, like that. So whenever you try to request and response data, just try to use the Postman also, so that you will get an idea how is the data coming, and if any error also there, like your data is not passing also, you can understand that this URL is not working properly. So based upon that, you can edit the data as well as the code also. Next is the data access with the Spring Data JPA. So it is a part of the Spring Data project, which aims to simplify data access in Spring application by providing a higher level abstraction over data access technology like JPA, MongoDB, Redis, etc. So in this, actually it is used to reduce the amount of boilerplate code which required for common data access, like in crud operation. That's the main thing that we are using, and sorting also we need Cory. So these three things we are mainly focusing for our exam thing, and a pagination also there. So this thing, the JPA thing, is needed mostly in the crud operation, sorting, pagination, and querying. So repositories in Spring Data JPA are interface that extend JPA repository or its subinterface and provide methods for querying and managing entities. In addition to query methods, the Spring Data JPA repositories support custom query methods annotated with at query, allowing developers to write complex query using JPQL or native SQL. So, um, the Spring Data JPA repository support a wide range of query methods. It's derived from method names, allowing developers to express queries using a familiar method syntax without writing JPQL or SQL queries manually. This is the entities that the ID generator value. These things are mostly seen in the model section, like what to say, the getter setter section, like that. Means in the object creating page, these type of things are present, like the entities like ID generator value, like that. So it is used represent persistent data in the application domain and typically correspond to tables in the database. And it the repository support basic root operations that already we mentioned, which allowing developers to interact with the underlying database without writing explicit SQL queries. So based upon this, we are using these type of entities, like whatever we giving in the database, it's we are connecting with the backend, like that. Next is the query method and custom query. So the Spring Data JPA repository support query methods, which methods defined in repository interface that follows specific naming convention, and which it is dynamically translated into SQL queries at runtime based on the method name parameters, eliminating the need for developers to write explicit SQL query. So based upon this, the among these things, the most things that you need is the Spring JPA, then the annotations, then the bean and profiles, then the DI and IOC. These four things you need mainly, because with these things you are going to do the hands-on from next session. So from the next session I will focus mainly on the hands-on part only, like creating projects, and after one project we will start the exam based coding, like test cases and everything. Based upon that I will prepare questions, and now also now only I prepared one type of question, which is like a library management system using the same exam pattern like what we done for the mini project, like that I done now. After first project I will upload the exam based project, so that you can understand how to give the mapping thing, the annotations, and the logic, business logics, like that you can understand. So based upon that you can prepare for the exam also. So if you didn't understand, or if you need this PPT, just ping in the comment box, I will share. So wait for the hands-on section. It will start from next video onwards. It is the last theoretical video for basic part. When I done with the first project, and some at least 2-3 project video that related to the Wings one. After that, I will start the advanced topic like JWT, and after that, one project related to JWT. Afterwards, I will try to create a exam based thing using JWT with the test case also. I will try to do that. So just wait for that. I will try to do it faster. So thank you for watching the video. Bye.